shall not be testing standard deviation, population standard deviation. We will not be testing population variance. Also, we will be testing population proportion. And it can be population mean for small sample and population proportion. So we are not going to be testing population standard deviation and variance. All right. The important thing is that we are doing population hypothesis testing for population proportion and population mean. All right. So we're going to just quickly do some review of vocabulary, and we start the hypothesis testing. So I already said that we shall be interested in testing for the mean of the population and the population proportion. Okay, so this is population mean, this is population proportion. All right. So there are procedures for testing. Step one, identify the claim. Somebody has to make a claim. So identify the claim. Identify the claim that somebody made. The claim. And a claim can sound like the average cost of a TI-84 calculator. The average cost of a TI-84 calculator is $100. So I will say that claim is, I would say maybe greater than that way. So the average cost of, I'll call this one claim A. The average cost of a TI-84 calculator is greater than $100. So this is the claim. And I am actually making it greater than $100. Okay, if somebody makes a claim like this, we call it a right tail test. Right tail. Right tail. Right tail test. And then if I am told to identify the claim, I will identify the claim as null hypothesis HO, the mu cost of TI-84 calculator is equal to $100. Why? You're going to ask me, why did I use equal to? Because the null hypothesis always uses equal sign. You cannot use another inequality for null hypothesis. Then the alternative hypothesis, you will now say the mu is greater than $100. So the alternative hypothesis states exactly what the claim is. Okay, and then suppose another test says B, the average cost of, suppose the mu says the average cost is equal to $100. Then I will state the claim. I will state the claim like this. So remember, the claim you state depends on what the person said. This time I'm using equal sign. This is what the claim said here. The claim said greater than. So for me to state the claim, I will say, I'm going to use black here. So it's stating the claim in B, I will say that the null hypothesis HO, the mu, the status quo, is equal to 100. And the alternative hypothesis, some books write HI, mu is not equal to. Because it says the average cost is equal to. So I am using two tails. So here I have 100. All right. And if I'm told to draw a picture I will draw a normal curve with a right tail test here. Why? Because the keyword says greater than. In this B, the keyword says the average cost is equal to 100. In other words, the alternative hypothesis is equal sign. So I am going to draw a normal curve. And when I draw a normal curve, I'm going to draw it here. So in this one, we call it two-tailed. When there is equal sign, it's two-tailed. Okay, so here the critical value, we shall call it Z alpha, if it is okay, Z alpha over 2, because it's two tails. Z alpha over 2, Z alpha over 2. If I'm doing a t-test, then I'll call it T alpha or T alpha over 2. Depends whether it's a small sample or a large sample. Well, another case could be somebody could say that the average cost of a calculus textbook or TI-84 calculator is less than. Its fitness is not equal to, it's less than. So this is C. So I'm going to state the claim for C. If I'm stating the claim, the null hypothesis is equal to mu, that is the cost, is equal to, because null hypothesis must always be equal sign. And the alternative hypothesis, don't forget to use colon. That's always going to be colon. Null hypothesis is equal sign. The alternative hypothesis is going to be less than, because the statement says says it's less than 100, so it's going to be less than. So actually there are three cases, and my calculator actually knows there are three cases. One case is greater than, case 1, case A, for at least, alternative hypothesis is greater than. Case 2, the alternative hypothesis is not equal to. Case 3, the alternative hypothesis is less than. Each one of them has you can draw a normal curve. So I'm going to draw a normal curve for case 3. And for this case 3, it's a one-tail left test. And so it's still going to be Z alpha if I'm doing a normal distribution test. Okay, by the way, this is 1. So we are going to talk about 2, identify alpha. So whenever you are told to do a hypothesis test, you must be given the alpha, the percentage of mistake. You're not, suppose you're given a confidence interval, you have a confidence interval of 95%, and remember that area under the normal curve is 100, then 100 minus 95 is 5. So your alpha is 5%. Okay, so I'm going to move this. So I'll just grab this, move it up. And then number 2, so identify alpha. Step 2, identify alpha. And when I identify alpha, I already know that alpha is 5%. And you always have to write alpha 0.05, change it to decimal. So if my alpha is 0.05, I am doing a one-tail left test. Then I'll find the critical value for alpha to the left. If my alpha is 0.05, one tail to the right, then I'll find the critical value alpha to the right. If I have alpha of 5% and doing a two-tail test, I divide alpha by 2. Okay, so the next step now is calculate the critical value. So when you know the alpha, you use alpha to calculate the critical value. So use your alpha. Use alpha to calculate the critical value. Calculate the critical value. And by the way, the alpha you use to calculate the critical value, it depends on the kind of test you're doing. If you're doing a t-test, then you calculate the critical value for t with n degrees of freedom, n minus 1 degrees of freedom. If you're doing confidence interval for proportion, then the test for proportion has to come in. Is NPQ greater than or equal to 10? Does it pass the test to convert from binomial to normal? Okay, if it does, then you do the test, one proportion z-test. Okay, so use alpha to calculate the critical value. So that is step 3. Critical value. Step 4 is calculate the test statistic. And it depends on the kind of test you're doing. If you are doing a z-test, there are 3 kinds of test statistics. So I'm going to just write it here. Calculate the test statistics. Calculate the test statistic. Okay, so if I'm calculating the test statistics, I am doing a proportion test. Then I will calculate the test statistics. I will just do, if I'm calculating for t or z, let's say it could be this. If it is z, then I will do z is equal to central limit theorem z. That's what we just talked about in the previous class, minus mean over standard error. But majority of the time, we don't actually have the mean, so we can we will divide by square root of sample size. Okay, so provided that we have simple random sample. So if it is a t-test, then we say t is equal to x bar minus mean over standard error for t, small sample divided by square root of sample size. And if it is a p, if I'm doing the test for p, then I calculate the critical value for p. Okay, so I will have p. I'm going to write this here. So p hat minus p. P hat is, remember, the sample proportion minus population proportion all over NPQ. We can just write p hat times q hat over sample size, where the test, the conditions for converting from binomial to normal is already met. So NPQ must be greater than 10, greater than or equal to 10, and sample size must be less than 5% of population. So the conditions must be met before I can do. So these are 3 kinds of test statistic that I can calculate. So this is greater than 5% of population. Sample size is greater than 5% of population. So remember, calculate the test statistic. And the test statistics can be z or t or p. All right. Okay, and if I'm doing this one, this is equal to ZP hat. ZP hat. In other words, this one is for random variables for p hat. This one is random variables for x bar, random variable in a small sample, and sample size is less than 30 in a t. The condition. Also, another condition is that population standard deviation is unknown. So these conditions must be met. Population standard deviation is unknown. So this is for P, this is for T, this is for Z. All right. And all of them, this must be from a simple random sample. If you're given a raw data for T, then it means you have to check the raw data and see, is there any outlier? And so this is, after you have come to calculate the test statistics, the next thing is to step 5 or number 5, conclude. Because after you do this, you calculate the test statistics, you now compare your test statistics and see if it falls into the rejection region or acceptance region. Okay. And then also you can calculate the p-value. Calculate the p-value or use your calculator. So calculate the p-value. If p-value is greater than alpha, reject the null hypothesis. Otherwise, accept the null. Okay, number 5, conclude. Conclude in non-technical terms. Conclude, make your conclusion in non-technical terms. So in number 5, conclusion in non-technical terms. In other words, those who sent you as a statistician to do the test, to do the hypothesis test, you want to tell them your findings in non-technical terms. So conclude in non-technical terms. Don't use null hypothesis, alternative hypothesis, and others. Okay. In non-technical terms, just tell them whether the status quo is still working or the status quo is not working. Non-technical terms. Okay. So we're going to see more. This is just introduction. So we're going to go, these are the steps, 5 steps in hypothesis testing. So these are 5 steps in hypothesis testing. I already said that in step 1, you identify the claim. Find what kind of claim are you having? You have a claim where somebody is claiming that the cost is greater than 100, then it's a right tail test. Or someone is claiming that the cost is equal to, which means exactly or has never changed. There are some keywords that will tell you whether it is never changed exactly, and that is a two-tailed test. Or is the person claiming that the cost is less than, because it's now less than, it's a left tail test. Whichever test you're doing has draw a normal curve and shed the region, and then calculate the critical value, identify the alpha, because one way or the other you are given the 5%, the level of significance. If you have confidence interval, then you are given the level of significance. Okay, then you calculate the critical value, and calculating the critical value will help you find, okay, what is the boundary line, so that if I finish calculating my test statistics and it falls into the boundary line, rejection region, then I will reject or accept. If it falls into the acceptance region, I will accept. Okay, so we will do an example. Let's go back and look at something more. So these are the steps we just talked about, so that you can go back and look at it. These are what I just said. If anytime anybody claims that the parameter is not equal to, It's a two-tailed test. You draw a normal curve with two tails. It depends on what the claim is saying. I just said that. If the person is claiming that if the person claims that it is to the right, then you will make sure that you draw the kind the normal curve and critical value that fits the claim. Your normal curve and critical value must fit the claim. Okay, so right now here, if someone claims a left tail claim, it means that you would draw a normal curve with a critical value on the left, like I just said before. Okay, and then if it is on the right, you draw a critical value and go ahead and so we're going to actually do an example. Doing an example will help, but one thing I want to mention is what is called error. What kind of error do we have? We're going to look for that. Sometimes we say there are two kinds of errors: alpha error, beta error. So how does that go? So I'm going to look for the errors and we want to identify them. Before you do, or anytime you do a hypothesis testing, there are two kinds of errors. There are two kinds of errors in hypothesis testing, okay? And we must know when we commit to one of them. All right, so two kinds of errors. Let's look at the options. It will be important that everybody who is doing hypothesis test knows how to draw this table and actually know how to interpret it. All right, so I'm going back to that error table and make sure. Okay, so in this error table, move it a little bit. Okay, so right here, whenever the null hypothesis, in other words, the status quo. If the status quo is true and you do not reject the null hypothesis. That is correct because the status quo is true. If the claim is true, then you made a correct decision. But if the alternative is true, in other words, the alternative is true, then you have committed an error. Committed an error called type 2 error. Why? Because you did not reject the claim when actually the alternative is true. If the alternative is true and you did not reject the null hypothesis, you committed type 2 error. All right. If the claim is true and you rejected the claim, you committed what is called type 1 error. But if the alternative is true and you rejected the alternative or the claim, you have not committed any error. So this is called alpha error. Type 1 error is called alpha error. Type 2 error is called beta error. So if you see beta error in your question, it means type 2 error. And what does type 2 error means? Type 2 error means that you accepted the claim. You did not reject the claim when the alternative is actually true. The alternative is true. In other words, the null hypothesis is false, but you did not reject it. When the null hypothesis is false and you did not reject it, you committed a type 2 error. But if the null hypothesis is true and you reject it, if the null hypothesis is true and you reject it, you committed type 1 error. I'm going to say that again. There are two errors in any hypothesis testing. If the null hypothesis is true and you reject it, you have committed type 1 error. But if the null hypothesis is false and you did not reject it, you committed type 2 error. And type 2 error is called beta error. Type 1 error is called alpha error. Okay, and so you will always see this question in a test. And they will ask you a type 2 error, a type 1 error, or what is type 1 error? Type 1 error is rejecting the null hypothesis when it's actually true. Type 1 error is rejecting the null hypothesis when it's actually true. That's type 1 error. Type 1 error is rejecting the null hypothesis when it's actually true. And type 2 error is do not rejecting the null hypothesis when it's false. Type 2 error, beta error, is not rejecting the null hypothesis when it's false. If you do not reject the null hypothesis when it's actually false, it's a beta error. Okay, so we're going to start doing examples now after this. All right.